So guys, yesterday we basically discussed about the incident management, incident response, how the containment strategy should be all about, and we also discussed about the root cause analysis, remediation phase, lessons learned. Then we also discussed about the RAID volumes, that is your redundancy array of independent disks. Now, when I am talking about the next two topics which is left, we are going to discuss is the BCP-DR plans, and then we are going to discuss the difference between the IDS versus the IPS. So now here when we are talking about BCP-DR plans, business continuity planning and disaster recovery plan, now there is a very thin line difference between BCP-DR. So now when we are talking about the BCP-DR plan, now there is a very thin line difference between business continuity plan and disaster recovery plan. Now, what's the difference? The difference between BCP and DR plan is BCP is not only related to IT. Okay. If I am talking about BCP, there are other elements of BCP plan as well. Like we have a IT contingency plan, we have a continuity of operations plan, we have an occupant emergency plan, we have a crisis communication plan. Okay, so we have a different kind of plan. So BCP is not related to only IT, whereas when I am talking about a disaster recovery plan, a disaster recovery plan is only related to IT. And now if I talk about your BCP, now there is another thin line difference between your BCP and DR. BCP is all about that in case of a disaster, how do we make sure that our services continue to run? That is what your BCP is all about. Disaster recovery means now the disaster is already striked. So how do we restore the business within the maximum tolerable downtime? So that is the reason why we say that disaster recovery plan is only related to IT. I repeat, disaster recovery plan is only related to IT. It is not, but when I talk about a BCP-DR, when I'm talking about BCP, there are other elements of BCP as well. Like we have a IT contingency plan, we have a crisis communication plan, we have a what do you call that? Uh, Occupant emergency plan, business resumption and recovery plan. So there are other elements of your BCP as well. So now if here we are talking about the disaster recovery. So just to take an example of a disaster of like an IT contingency plan, let me give you a live example. So let's say team currently we basically have a data center. We basically have a data center which is based out in Mumbai region. Guys, can you please keep your mics on mute? Thank you. Because the session is getting recorded. So let's say currently we have a primary site in Mumbai region. Okay, now this is my primary site. This is my primary site. Now currently in my primary site, I have actually 5 servers. I have actually 5 servers, which together it is handling a load of almost 50,000 users. Okay, so currently we have my primary site in Mumbai region, which is currently having 5 servers. Together it is handling a load of 50,000 users. 50,000 users. Just a second. Now let's say that I have to define an IT contingency plan, that tomorrow if my primary site goes down, my business operations should continue. Whatever critical business units I have identified during my BIA, it should continue to run even with 50% capacity. So what I did, so this is my primary site. So basically I, in the same Mumbai location, I am having an alternate site as well. Okay, in the same Mumbai location, I am having an alternate site. So this is my alternate site. Okay, now currently the alternate site is somewhere. So like in my primary site, I have 5 servers. In the alternate side, probably I am only having three servers. In the alternate side, I am currently only having three servers. So which means that once the primary site is gone down, the entire 50,000 users will be failed over to the alternate site, which means right now my alternate site is running with 50% capacity. It is running with 50% capacity. So my business operations will continue to run. Okay, but there will definitely be performance issues, latency issues and all, but at least it will not become a single point of failure. Now my risk assessment team, they have identified that this alternate site can will be able to handle 50,000 users maximum for 3 hours. After 3 hours, even this will go down. It will not be able to serve anyone. So now what is the option we have left? So now let's say I have a DR site. I basically have a DR site, which is, let's say it is based out in Chennai location. My DR site is based out in Chennai location. Now what I have to do? That within these 3 hours, I have to make sure that my Chennai data center is up, and in the disaster recovery, so in the Chennai side, I have to make sure that I have to bring my Chennai site up and running within this 3 hours before my alternate site goes down. So that is what is my, this is one live example of a IT contingency plan. So this is what the difference between your IT contingency plan. Now when I am talking about the disaster recovery plan, a disaster recovery is nothing but it is a site which is a location that allows the organization to restore the data, critical infrastructure and essential business operations in the event of an unexpected event. Now basically even the DR plans, there we have three types. Now what are the three types? We have a hot site, we have a warm site, and we have a cold site. Okay, but now there is one another thing which is there, which is also called as a mirror site. Now what do you mean by mirror site? Mirror site, now whenever we are talking about, so now when we are talking about, the BCP DR plan, so we have a hot site, we have a warm site, we have a cold disaster recovery site as well. Now when I am talking about hot site, before we talk about hot site, we also need to discuss something about your mirror site. Now what do you mean by mirror site? Mirror site means it is the exact replica of your primary site. So now whenever we are talking about hot site, warm site, mirror site, we basically use a word which is called as your PPT. Now what do you mean by PPT? It is not your PowerPoint template. It is basically, PPT stands for people, process and technology. So now when I am talking about a mirror site, mirror site is one of the most expensive site which an organization can have. So basically you are mirroring the entire primary site. It means that there is no downtime. So we have a people, we have a process, we have a technology and we have a data. So in a mirror site, okay, in a mirror site there is no downtime at all, because whatever changes is happening on the primary side, it is immediately replicated or synchronized with the mirror side. So you can say your mirror side is just like your active slash active, active slash active cluster, active slash active cluster. So whatever changes is happening on the primary side, it is immediately getting replicated to the secondary side. So in a mirror side, we basically have a people, we have a process, we have a technology and we have a data. And it is basically your synchronous replication. It means even if one bit of changes happen, immediately it is replicated to the mirror side. That is the reason any question in the exam, now when you are preparing for the CCSP exam, okay, sorry, CISSP exam, any question on the exam talking about which one is the most costliest kind of disaster recovery site which we have, the answer is your mirror site. The answer is your mirror site. Okay, now the next is we have a hot site. Now what do you mean by hot site? A hot disaster recovery site mirrors the capabilities of the primary location as fully as possible and can be up and running almost immediately with minimum disruption. So in the hot site, we have a people process technology, but the data is not, we don't have live data, means we don't have up to date data. So now what do you mean by up to date data? So let's say currently team that I have a primary site. Okay, I have a primary site and I have a secondary site. Okay, I have a primary site and I have a secondary site. Now there is basically a replication which is configured to happen between the primary and secondary. Now this replication, whatever changes is happening in the primary side in regards to the people, process, technology and data, it is replicating every 1 hour. Every 1 hour the changes are getting replicated from the primary side to the secondary side. Okay, so now let's say if at 9 a.m. there was a successful replication, at 9 a.m. there was a successful replication between the primary site and the secondary site. Okay, which means that the next replication is going to happen at 10 a.m. because it's an hourly replication. Now before that replication occurs, if the primary site goes down, which means that either the organization has to accept that 1 hour of data loss, which is as per the RPO, or they, if they have a specific backups for that 1 hour of data loss, then they have to manually copy those backup files to the secondary side and replay it against the database or server. That is the reason why we say that in the hot side we have a people, process, technology and data, but the data is not like, it is not a live copy of data. There might be some delay depending on the replication cycle which is being configured. So I believe the difference between the warm site and hot site is clear. I believe the difference between the warm site and hot site is clear. Now the next is we have a warm site. Now what do you mean by a warm site? A warm disaster recovery site, it includes key equipment and functionality, but it takes longer to set up and does not have the complete data and full functionality offered by a hot site. So any question in the exam talking about cost effective, okay, any question in the exam, CISSP exam talking about cost effectiveness, okay, the answer is your warm site. Because in the warm site we basically have the people, process. Okay, we have the people, we have the process, we have an internet connection, we basically have the racks, but we do not have the server and data. So what is missing in the warm site is the server and data. So now if your site has a like a recovery, so let's say if your organization has a maximum tolerable downtime of, let's say, 6 hours or 7 hours, in that case you can basically go for a warm site where we have a people, process, we have a internet connection, we have HVAC, heating, ventilation and air condition system, we basically have your racks. Okay, but we do not have the server and data. So in case of a disaster we have to move the server, we have to move the data and then bring the and start performing the recovery. That is the reason why we say the warm site is one of the cost effective comparative to your hot site and mirror site. Now there is also one more site which is called as your cold site, which is a disaster recovery site, which include basic systems such as power and cooling, but there is no internet connection, there is no racks, there is no server, there is nothing. Okay, so basically as you can see that a cold site will take longer to recover. So like if you have an organization which has a maximum tolerable downtime of weeks, like it will come up within 3 to 4 weeks or within 1 month, in those cases you may go for a cold site. But you might be wondering, like, which organization in today's world, which organization will have a maximum tolerable downtime of, let's say, 15 days or 20 days or 1 month? Well, normally the organization can have a, the organization go for the cold recovery site when they are already having a secondary site running in like a public cloud provider, like it can be your AWS, it can be your Azure, or it can be your GCP. So when the company's disaster recovery plan is already running, their secondary site is already running in a public cloud, like in a AWS, Azure, or GCP, so their business operations are not getting impacted, right? Their business operations are not getting impacted. In that case, they can take even weeks or months to build their cold site and then perform the failback. So that is what your cold recovery site is all about. That is what your cold recovery site is all about. So now when we are talking about a disaster recovery plan, so how the disaster recovery plan should be designed? A disaster recovery DR means Saumik, I didn't get your question. So the location, it should be based out. So if we are talking about the location, like building the disaster recovery site, so if you are normally the location constraints which are there, so your DR site should be far away. It should be far, whatever. So it's like the guidelines which are being set for setting up a disaster recovery site is in such a way that whatever disaster is impacting your primary site, it should not impact your secondary site. So the DR site should be as far as possible where it should, but at the same time, if tomorrow you want to travel to the disaster recovery site for performing the recovery, it should be far from the primary site, but it should not be too far where you are taking days to reach the disaster recovery site. It should be within like 3 4 hours, 5 hours duration. Okay, so that is how your disaster recovery site should be planned. So the same kind of near DR, yes. So now here when we are talking about near disaster recovery and far DR, the secondary site, yeah, the secondary site should be little far away from the primary site. So like so in order to take an example, your primary and secondary site should not be both in the same location. Okay, so like my primary site is in Tokyo, my secondary site should not be in Tokyo, because tomorrow if there is an earthquake, it is not only going to impact my primary site, but it's going to impact my secondary site. So it should be far away, far as much as possible, but at the same time the commute time should be less. So tomorrow if you want to travel to the secondary site, within 2 3 hours you should be able to travel. That is how the guidelines which has been set for setting up a disaster recovery site. Wherever, whichever location you are choosing to build your secondary site, whether they are same power grid or power provider is available in that site, even the internet connection which you are going to choose for building the secondary data center, whether that internet connection is like an internet service provider like Airtel, Jio, or Vodafone, or if there is any local provider, because and if there is a local provider from where you are leasing the internet connection, then you need to do the risk assessment that does this local provider is leasing this internet connection from anyone, because if they are leasing it from some another provider, tomorrow if there is a downtime on there, and it will impact it will impact us as well. So the power grid is the main concern which is available. Okay, the second concern is your internet connection, people commute, transport. So there are multiple factors which must be taken into consideration before you choose a location for the disaster recovery. And at the same time, even the regulation consideration must be taken into consideration. So your secondary site should be within the region. It should not happen like you are collecting data, your primary site is in EU location and your secondary site is in India location, because that will and if you are collecting the PII data and all, then the data localization concern will come if you are following under the GDPR principle and all. So all these factors must be taken into the consideration before you choose the disaster recovery site. Now when we are talking about the disaster recovery, it means to restore services from a contingency state DR typically performs the task across several areas, including response, personal communication, assessment, restoration, and training. So now what all factors the plan should include? So the plan should include the activation and recovery procedures. We should have a proper plan management. So now what do you mean by plan management team over here? The plan management means we should have a proper version control. We should have a proper version control. So like only the current and latest version of the disaster recovery plan should be maintained. Okay, all older versions of the document should be discarded and removed from the system, because tomorrow it should not happen that when the disaster has during the disaster your recovery team is getting confused that which documentation they have to follow. So only we need to have the proper version control of the BCP-DR plan. Now, not only we should keep a copy of the BCP-DR plan in the secondary site, but it is also advisable that we also, you know, keep a hard copy of the BCP-DR plan in the secondary site. So, because tomorrow, if there is a disaster strike, like an earthquake or like a seismic activity, where internet connection is not available, so in that case you should have a hard copy available with you, which can be used by your disaster recovery team to start the recovery procedure. We need the involvement of the human resources, because if you have a maximum tolerable downtime where we say that within 3 hours, within 6 hours you need to bring the critical services up, then we need to shift the people from one location to another location. We may have to plan 3 shifts. So we need involvement not only from the HR department, we also need involvement from the admin department for arranging the commute and transport. We need to make sure that if people are working in 3 shifts to perform the recovery, then they have enough water, food supply, everything is available. So all these factors must be taken into consideration. So that is the why the human resource involvement must be included. We must identify the cost. What is the documentation required? We need to identify the internal and external communication. So like the disaster recovery team will be definitely, the DR team will be led by a project manager or a team lead. Okay, so they need to track like how much of the recovery is actually completed. Now they may have to, whoever is leading the disaster recovery team, they may have to work with the auditors. They may have to work with the spokesperson to inform the media that how much time it is going to take for the entire site to come up. That is the reason our internal and external communications must be taken into consideration when we are planning for a disaster recovery site. And finally, detailed action plan per team and team member is equally important. So what during a disaster, what should be the role and responsibility? What what is the procedure? What is the role and responsibility of each and every individual? That should be clearly documented and distributed based on need to know basis team. Now, why I am saying this? Because the design said that the BCP-DR plan is so detailed we hire a college fresher who doesn't have experience in performing any kind of BCP-DR, they should be able to follow the documentation and perform the recovery. I repeat, they should be able to follow the documentation and perform the recovery. That is the reason why we say detailed action plan per team and team member must be mentioned. So this is what things are required. So plan must be detailed, so a person with skills but without experience will be able to execute the procedures and could perform the recovery. They can perform the recovery. So now when we are talking about the DRP teams, so we have a 3 types. We have a recovery team, and we have a salvage team. Now what do you mean by a rescue team? Rescue team is responsible for dealing immediacy of disaster employee evacuation, like crashing the server room and etc. So basically, during the disaster, like making sure that who are there within the data center, all people who are there within the data center so for emergency exit, making sure that everyone has successfully evacuated. All these are the responsibility of the rescue team. Finally, we have a recovery team. Recovery team is responsible for getting the alternate facility up and running and restoring the most critical services first. So this is where your disaster recovery team comes into the picture. These are the people who are going to report to the alternate site and perform the recovery procedure, depending on what kind of critical services they need to restore first. So for this, basically, they need to refer the documentation of the BIA. So during your BIA, whichever critical services has been identified first, those needs to be restored. So now always remember, team, from the exam point of view, you need to remember one thing more, that is during a failover. I repeat, during the failover, we always restore the most critical services first. So please make a note of this. During the restore, we always restore the most critical services first. And during failback, when we are failing back to our primary site, we will restore the non-critical services first. So during failover, we restore the critical services, and during failback, we restore the non-critical services. Now, why do we restore the non-critical services first? To check that whether our primary site where we are failing back, whether it is capable or it is fully up and running to handle the critical services. So that is the reason during failback, we always restore the non-critical services first, then we restore the critical. Now the next is we have a salvage, which is responsible. Salvage team is responsible for the return of operation to the original or permanent facility, which is again called as your reconstitution. So now what is the how to maintain the BCP? So keeping plan up to date, it is a critical factor, making it a part of business meeting and decisions. So there should be a centralized person to whom we should define, we should give the authority, whose responsibility will be to make sure that the BCP DR plan is maintained up to date. Okay, so it doesn't matter how big or small changes is happening in the organization, the BCP DR plan should be updated and proper version control should be done on the BCP DR plan. So making it as a so reviewing the BCP DR plan, okay, on an annual basis or on every quarter or once in every 6 months, this is what is recommended. If once in every 6 months is not possible, reviewing it annually over the business meetings, that is one thing which is mandatory, every organization should do. There should be a centralized responsibility who is for, and it should be given to a person who will be responsible for making sure that the BCP DR plan is kept up to date. It should be part of the job description. Okay, we should evaluate the people, make sure that they know what is their role and responsibilities in terms of BCP DR, because always in the organization existing employees will leave, new employees will join. So existing employees may retire, they may get terminated, they may change their job. So whoever is replacing them, they should be they should be aware what is their role and responsibility in terms of BCPDR. Where do they fall in this entire recovery procedure? So that needs to be clearly documented. We need to report regularly, conduct audits to make sure that our BCPDR plan is effective. And as plans get revised, original copies should be retrieved and it should be destroyed. So these are some important elements for maintaining the BCP. Now the next is we have a IDS and IPS. So now intrusion detection system and intrusion prevention system. Now people who are preparing for the CISSP, at the same time people who are preparing for the CCSP, these topics are quite testable. the IDS and IPS. So the intrusion detection system is a technology that alerts the organization to adverse or unwanted activity. And IPS, it monitors the activity like an IDS, but automatically takes preventive action if unacceptable activity is detected. So the intrusion detection system is more like, you can say, it's a kind of your detection tool. It is only going to detect and report. It is not going to block or prevent any action, take any action, right? So now when I am talking about, so proper placement of your intrusion detection device, I repeat, proper placement of your intrusion detection device is equally important. So now let us take a scenario. Okay, let us take a scenario. Let's see that we have a internet. We have a internet. We have a packet filtering firewall. We have a packet filtering firewall. Then we basically have a DMZ. Okay, now in the DMZ, we have a web server, we have a DNS server, we have a mail server. Then we have another firewall. We have another firewall. And then we basically have your intranet. Now in this intranet, we basically have a AD, Active Directory Domain Controller. We basically have a database server, and we basically have a, let's say, a file server. Now as a security architect or as a CISO, you need to determine the placement of installing an IDS. So now you tell me where exactly. Now I want to check the effectiveness of my packet filtering firewall, that whether my packet filtering firewall is effective or not in blocking the attacks or blocking the traffic. So where will I place the IDS? Will I place it here or will I place it here to check that whether my packet filtering firewall is effective or not? Definitely I will be placing behind the packet filtering firewall, because if I place it before, it is going to have a lot of false positives, right? It is going to have a lot of false positives, so which is something which we don't need. That is the reason why we specifically say that the packet filter, the IDS will always be placed behind the packet filtering firewall to check the effectiveness, that what kind of attacks or packets which is being missed. So the proper placement of the devices is also equally important. Now the next question is, let's say if your organization tomorrow comes and says that you have acquired or you have purchased a IDS of Palo Alto, IDS and IPS. So now the question is, now your organization is concerned, your organization doesn't have an understanding of what is normal, what should be allowed versus what should be blocked. In that case, if you place the IDS and IPS in an active mode, what will happen? The impact of the placing the IDS in the active mode, when there is no baseline, it means that even the legitimate traffic will be blocked, right? Which will become a single point of failure, which we do not want, right? So that is the reason why normally it is specifically for those organizations who doesn't have a clear understanding of what is normal and what should be allowed versus what should be blocked. They initially place their IDS on a passive mode, where they allow the IDS to build a baseline to learn the traffic, and then once the learning stage is completed, then they place the IDS in active mode, which basically starts taking preventing action like blocking the traffic. But in the initial phase itself, if you configure your IDS and IPS in active mode, what would be the impact? Even the legitimate traffic will be blocked. Even the legitimate traffic will be blocked. That would be the impact. So that is what your IDS and IPS is all about. That is what your IDS and IPS is all about. So now when we are talking about the analysis methods, so we have several analysis methods which can be employed by an intrusion detection system. So now what are the different kind of activities which are available? We basically have an IDS and IPS which can learn a standard activity baseline which is normal to the organization. Deviations from this baseline of expected behavior are deemed suspect. So now in the deviation base, okay, in the deviation base, we are actually defining in the IDS what is normal. We are actually telling the IDS what is normal versus what is not normal. So now in order to take it as a use case, if I have to take a use case for this, so now in the deviation, so as I was explaining about the use case, so in the deviation based IDS and IPS, so one live use case I can give you where we are actually defining a baseline. So I am specifying that one use case I can take for this is, if my database server is going for a reboot, okay, if my database server going for a reboot over the weekends between 12 to 12:10, during that time if there is any failed logins coming, okay, do not alert it. You store it, but you should not alert. You should not create, offenses for that. You should not create incidents for that. So this is one live use case. Okay, so during my database server goes for, like, my database server goes for a weekly reboot. So during between midnight 12 to 12:10, if there is a reboot activity going on, I am not saying that the fail logins which are happening during that time, it should not be captured. It should be captured and stored, but at least it should not create incidents or it should not trigger an alert. So this kind of activity I am defining. One another use case I am defining is, if the count of fail logins is 3 during Monday to Friday during normal business hours. If the count of fail login is 3 during Monday to Friday during normal business hours, I don't want to have an incident for that. Okay, I just want an alert, but it should not go ahead and create an incident. So this kind of baseline I have to configure in the deviation based IDS and IPS. Okay, like if someone, one another use case I can give you, if someone is basically executing stored procedure on the database, like over the weekend we basically have configured a stored procedure on the database which basically creates a snapshot of the tables. So now during that stored procedure, I don't want that my IDS and IPS should trigger an alert like data extraction alert just because of a stored procedure is getting executed. So this kind of baseline I need to configure on my deviation based IDS and IPS. So basically with the help of deviation based IDS and IPS, we are telling that this is what is normal and this is what, anything which is outside of this is abnormal. But now the next is, we have a signature based IDS and IPS. Now what do you mean by the signature based IDS and IPS? The signature based IDS and IPS, it can recognize known attack patterns in traffic and activity. But what is the problem with the signature based IDS and IPS team? The problem with the signature based IDS and IPS is that it does not have, or it is not capable enough to identify 0-day attacks for which there is no signature. Now another problem is, if your IDS and IPS signature updates are not latest, even then it is going to have issues. Even then it is going to have issues. So that is the reason why we say the signature based IDS and IPS can recognize known attack patterns in traffic and activity. So in a way, I can say that your antivirus and anti-malware, they are all actually your signature-based antivirus solution only. The antivirus is only effective as long as their signatures are up to date. Okay. Now the last one is which is we have is your heuristic base. So machine learning algorithms in the IDS and IPS can acquire more information about the environment as the tool operates beyond a simple baseline. This is an advanced form of deviation analysis. So now when we are talking about heuristic, here we are taking help of machine learning. So live example, here we are taking help of your IBM Watson or your threat analytics feature of IBM or X-Force Exchange, where they are learning the historical data, where they are doing the analysis of historical data and building a baseline. Now this baseline which is being analyzed by machine learning, it will definitely have some false positives, and definitely you need to fine tune it. Okay, so like one live example of this heuristic, in fact, when you start using SIM in the first place, now many customers, they think that when they implement SIM, okay, initial 6 months to 1 year, it is not about only SIM. Any kind of monitoring tool, whether it is your file activity monitoring, whether it is your network activity, like whether it's your file activity monitoring like tripwire or stealth bits you are using, or if you are using a database activity monitoring like imperva guardium, or you are using a SIM solution, the it minimum takes 6 months to 1 year for the product to get much more mature, because initially when you start using the product, the 65 to 70% of the time the SOC analysis, they will actually initial their 6 months to 1 year, they will basically take to fine tune the alerts to reduce the false positives. Once your rules are much more granularized, then only you will start getting the actual data. Initially, any kind of monitoring tools you procure, minimum 6 months it takes for the product to start producing the actual results. So when we are using things like user behavioral, user and entity behavioral analytics, or user behavioral analytics app and all, which is totally built on machine learning, definitely it is going to build a baseline, but definitely it will have false positives. So you need to fine tune it. So this is what your deviation, signature and heuristic based IDS analysis methods we have. Now apart from this, now we also have another method which is called as your, so now what is the key point which you need to remember from the exam, which is applicable for both CISSP and people who are preparing for CCSP as well. The types of intrusion given the highest priority should be those that have the potential to realize the risk which we have identified during the risk management plan. Now, if you have attended my yesterday's session, even during my incident management topic, I mentioned those which has been identified which can impact your BIA, okay, which can impact your BIA during your risk assessment. Those should be given highest priority. The same is applicable even in the IDS method. So the types of intrusions should be given the highest priority should be those that you have identified during your risk management plan or during your risk assessment. Now when we are talking about, now the next kind of IDS and IPS method which we have is your anomaly detection. Now, what do you mean by anomalies? Anomalies may include multiple failed login attempts. So, live example, some of the use cases like an employee connecting during strange hours, an employee connecting to the organization VPN over strange hours, like outside of business hours, or over the weekends, or over the public holidays. Okay, they are actually trying to, your employees, your privileged user, they are actually trying to touch a sensitive table which ideally they are not supposed to touch. Okay, or they are using excessive usage of administrative command, like excessive usage of bulk, insert, truncate, drop. These kind of commands are being these kind of commands are being run more on the database server. So these are some kind of deviations or anomalies which are identified by the IDS and IPS, and based on that, now you must have seen nowadays majority of your SIM solutions like IBM QRadar or Splunk, or for that matter your even your SOAR, they basically have something called as a risk scoring method, right? So depending on the behavior of the user, what the user is behaving differently, they do something called as a peer group analysis. And if their peer groups are, if the activity of that individual user is deviating from the peer group, it basically, depending on the kind of analysis, depending the kind of deviation, it assigns a risk score. So some users will have a risk scoring of between 1 to 5. Some users will be having the risk score between 8, 9 and 10. So these are all live examples of your anomaly detection. So like multiple failed login attempts. Now in under ideal circumstances, failed login attempts should come from normal users, but do we expect failed login attempts should come from service account as well? For that matter, do we even receive failed login attempts coming from service accounts which we are using? So even if a failed login attempt coming from service account, that is also a kind of anomaly. Might be possible that someone is using the service account, right? And they are trying to do a lateral movement or privilege escalation. So that is the reason why multiple failed login attempts, not only from the user account, but even if it is coming from a guest or service account, we need to capture it. User logging in at strange hours. So like outside of business hours, during weekends or public holidays, they are connecting. Okay, unexplained changes to the system clocks. So ideally, under all circumstances, the NTP, all the endpoints are synchronized with an NTP server. But if there are unexplained changes to the system clock, those should be captured. Any kind of unusual error messages which you are getting, any unexplained, or all of a sudden your system went for a shutdown or reboot. Yeah, like all of a sudden your database server went for a reboot. Okay, during your business hours or during the weekdays, your database server like your Oracle or MS SQL database server went for a reboot, which was not planned. Or any process in the system, any process in the system trying to access some restricted files, all these are anomalies which should be captured. At the same time, it should be triggered. So an anomaly based IDS, it tends to produce more data because anything outside of the expected behavior should be reported. Now when we are talking about the intrusion detection system team, so we have a traditional intrusion detection and we have an anomaly. So we have basically two types. We have a pattern matching and we have a stateful matching under pattern. Then we have an anomaly based engine where we have three types, where we have a statistical anomaly, we have a protocol anomaly, and we have a traffic anomaly. So now first we are going to discuss the pattern matching intrusion detection system. Now when I say pattern matching, okay, so don't get, I have seen many participants or many aspirants who are actually preparing for the CISSP, they tend to get very confused between your pattern matching and your stateful matching. So I will give you a simple layman example which will clear your doubts once and for all. So pattern matching intrusion detection is just like your packet filtering firewall. So like everyone is aware that in Windows, we basically have a packet filtering firewall. We have a Windows firewall, right? Now in Windows firewall, we basically have an inbound rule and we have an outbound rule, right? So we have an inbound rule and we have an outbound rule. So if we have to allow a traffic to come in, we have to create an inbound rule. And if we have to allow a traffic to go outside of our system, we need to create an outbound rule, right? So that is a live example, and the Windows firewall is a perfect example which works on packet, which is called as your packet filtering firewall. Now, why do we say it is a packet filtering firewall? Because the entire decision of allowing the traffic or denying the traffic, it is based on the IP header. It is based on the IP header. Okay, it doesn't perform the layer 7 packet inspection. So that is the reason why we say that Windows firewall or packet filtering firewall, they have a very basic capability. Now, when I am talking about now, so in all, if someone asks you a question, does your pattern matching is your Windows firewall or is your packet filtering firewall, okay, or your pattern matching intrusion detection, is it capable enough to identify complex attacks like a DOS attack or a DDoS attack, where you in the SIM solution, we basically in the SIM we have something called as a super flow. So super flow means where there is one source and multiple destination. Okay, when there is one, when the source IP is one and multiple destination IP, or multiple destination IP is targeting one source. So live example, when you do an nmap scan, okay, to identify how many ports are open, you are executing an nmap scan from one system and you are actually scanning a bunch of database servers, right? So that's a live example of a super flow where the source IP will be same, source port number will also be same, only the destination IP and the destination port will be keep on changing. So that's a live example of a super flow. Okay, so now the problem with the pattern matching intrusion detection is that in the pattern matching intrusion detection, it is not having the capability to identify complex attacks like DOS attack or DDoS attack. Or another live example I can give you of the pattern matching intrusion detection is like now, because of Netflix, Amazon Prime, we have your Apple TV and so many media streaming apps which we are having, CDN solutions we are having. That's the reason why majority of us are not using torrents. But there was a time where we used to use a lot of torrent to download games, movies and softwares and all. So in if you would have seen, if you have used at any point of time in your career, if you would have used BitTorrent or uTorrent, you must have seen that the files which are downloaded, it is downloaded from multiple peers from in the form of small sizes, right? So now if there is an attack coming from multiple sources, okay, your IDS should be able to correlate the packet. If we want to identify a DOS attack or a DDoS attack team, then your pattern matching intrusion detection should be able to correlate the activity, right? But the problem is the pattern matching intrusion detection, it performs inspection on individual packet level. It doesn't correlate the packets. So that is the reason why it is not having the capability to identify complex attacks, because in order to identify the complex attack, you need to do a series of packet inspection. You need to do a series of packet inspection, right? So that is the reason why we say that the pattern matching intrusion detection works on an individual packet level. It works on an individual packet level. It doesn't work on the this level, what do you call that, on a series of packets. That is the reason why it doesn't have the capability to identify complex attacks. It doesn't have the capability to identify the complex attacks. So that is what your pattern matching intrusion detection is all about. So now the next is team, we have a stateful matching intrusion detection. So in the stateful matching, as I have mentioned, that in the pattern matching, whatever the gaps was there, where it was not able to perform the analysis of it was the pattern matching was doing analysis on an individual packet level rather than a series of packet. In stateful matching intrusion detection, it can actually do the analysis on a series of packets. That is the reason why the stateful matching intrusion detection, it is having the capability to identify complex attacks coming like your DOS attack, DDoS attack, anyone is using torrent or anyone is using nmap or wireshark. So this kind of application, if someone is using in your organization, your stateful matching intrusion detection will be able to flag that alert. So that is what the difference between pattern and stateful matching. Now when we are talking about anomaly based engine, now, when we are talking about the anomaly based engine, in the anomaly based engine, we have a three types. We have a statistical anomaly, we have a protocol anomaly, and we have a traffic anomaly. Now, what is the difference between statistical, protocol, and traffic? The difference between the statistical, protocol, and anomaly is, see, don't get confused. The statistical and traffic anomaly is mostly one and the same thing only. So the statistics anomaly based intrusion detection or the traffic anomaly, it basically identify when a network application is, if there is a change in the statistics. So like you have a Microsoft Teams. Now all of a sudden your Microsoft Teams, or let's say your web server, is sending excessive amount of traffic to the outbound. Or let's say if there is a database server over the weekend, and the outbound traffic of a database server or a web server over the weekend is too much, it is exceeding 10 gigs or 20 gigs. So there might be possible that your web server is actually controlled by a botnet, and someone is trying to exfiltrate the data during weekends. So your statistical anomaly, whenever a network or a user is behaving differently, that is what your statistical anomaly based intrusion detection is going to flag that alert. Now when we are talking about traffic anomaly, so now what do you mean by traffic anomaly? Like, let's say your web server is having a IP. Now you have 5 web servers. The range of IP is between 10.1.1.1 to 10.1.1.5. Okay. Now let's say team that all of a sudden there is a new web server, which is there is a new activity web server, port, there is a new activity coming on port number 80 or port number 443 from 10.1.1.6. Now this is basically an anomaly which was not seen previously. Or there is altogether a new user is found, a new DNS server is found, okay, or a new DHCP server became operational. This kind of activity will be identified based on the traffic based anomaly intrusion detection. So when there is a new port, a new server is seen from where earlier there was no traffic, then those will be flagged by the traffic based anomaly based intrusion detection system. And now what do you mean by a protocol based anomaly intrusion detection system, team? The protocol based anomaly intrusion detection system, it basically keeps a track of all the RFC standards. So like every port, so basically we have a 65,535 applications and ports. So for each and every application, we have a RFC standard, request for comment. So whenever any protocol is deviating from the standard, okay, it triggers an alert. That is what your protocol based. But you have to understand one thing from the exam point of view, that the protocol based intrusion detection system cannot identify complex protocols like REST API or SOAP. Your REST API and SOAP, because they work on the XML language and all. So if you are using your protocol based anomaly, they are not capable enough to identify complex protocols like REST API and SOAP and all. So that is what your statistical, protocol, and traffic based anomaly is all about. Now when we are talking about, so in the statistical base, develop a baseline of normal traffic activities and throughput. It can identify unknown attacks and DOS. The organization must have a clear understanding of normal traffic for IDS tuning. Now when we are talking about the protocol anomaly, in the protocol anomaly, it can identify unknown attacks, but it may not handle complex protocols like SOAP and XML, and it looks for the deviation in standard. So that is what your anomaly based engine is all about. Now when we are talking about The next is we have a NIDS architecture. Now, what do you mean by NIDS? NIDS means your network intrusion detection system. It is usually incorporated into the network in a passive architecture. This means that the system. Okay, now the next is we have a NIDS network-based intrusion detection system can also fail to provide adequate monitoring if the traffic it is monitoring is encrypted. So as I have mentioned that your IDS and IPS, they can monitor and block the traffic as long as it is not encrypted. But if it is encrypted, then it can fail to provide adequate monitoring. This is a key point which you need to remember from the exam point of view. Now, when we are talking about your organizations, they must be careful, though, as user training and privacy concern must be taken into consideration at all times, balanced with the security requirement. Now, if you are you must have seen in the organization, right, that we have the screensavers which says that your activity is being monitored. So if you are monitoring their activity, it should be notified. You should not do, secret monitoring, which can impact the privacy of your employees. So that is the reason why we say the organizations must be careful, though, as user training and privacy concerns must be taken into the consideration and at times should be balanced with the security requirement. Finally, we have the HITS, which is also called as your host-based intrusion detection system. Now, the host-based intrusion detection system is the implementation of the IDS capability at the host level. So now what is the difference between your network-based intrusion detection system? The network-based intrusion detection system performs the filtering. It performs the filtering on the network level, whereas your host-based intrusion detection system, it performs the discovery on the host level. That is the reason why we say that when you are talking about the intrusion detection system which is happening on the host level, it is it can impact it can be very CPU intensive to the host operating system. That is the reason many organizations, they don't allow the host based intrusion detection system to be even installed on their server. Like I have worked with some of my in my past days, I have worked with some of Saudi and Dubai customers who were so much rigid that they didn't even when I was handling a database activity monitoring project, they didn't even allow to install an agent on the database server because fearing that they may impact the performance. So because of that, we have to use an alternate approach like NTAP or span port monitoring to monitor the database throughout the network. So the same way, the biggest problem of your host-based intrusion detection system is that it can consume inordinate amounts of CPU and memory to function effectively. That is the reason why the host-based intrusion detection system is not that widely. So that concludes our all the topics which we discussed.